Hello, everyone, and thank you for joining today's NKBA KBIS design webinar, LED and Light Sabers. As we continue our theme of lighting and design for May, I'd like to give a huge thank you to Hardware Resources for sponsoring this month's design and business webinar series. Please join me in welcoming today's speaker, Keith Harrison, CEO of Total Home Technologies. Keith, please take it away.
Good afternoon, everybody. Wanted to say hello. Wanted to make sure everybody can hear and see the presentation that's up on the screen at the moment. It looks like there's over 100 people on this webinar today. Fantastic. Quick shout out. Just type in yes or I have if you've been to any of my webinars in the past. Just kind of curious to see how many other people have seen something like this from me in the past. My name is Keith Harrison. I'm the CEO of Total Home Technologies. We are an integrator in the metro New York area, covering New York and New Jersey. And occasionally we have travel jobs where we go and work on people's homes all around the country, and occasionally, when I'm lucky, all around the world. I founded this company in 1992, so I've been doing this for a minute or two at this point. Thank you guys for all joining. The reason I call this LEDs and lightsabers is because everybody thinks they know what an LED is. And most people know they don't know what a lightsaber is or how it works, because we really don't understand either. We have the perception that we understand LEDs, but hopefully I'm going to challenge that perception today and give you some education on that. A little bit about me. I like taking things, and two favorite things in my life. I'm an aerospace engineer by study, and I'm a big snowboarder. So I like to take two things that I love and put them together. And here's a funny little clip of my 2 seconds of fame that I got on a commercial for a bunch of years back, where I built a rocket-powered snowboarder. Yes, that is real and not video trickery. If you guys want to know how I did it, they'll reach out to me and I'll happily give you the plans and you can build one of your own. Let's just talk quickly about the history of lighting. So, in lighting, we've got a long history of this stuff, right? So we've been using artificial lighting for quite a long time, because anything other than sunlight is artificial lighting. So if we take a look at candles and oil lamps, right? We've been using them up until the early 1900s. People still use them, actually. And it was our first portable artificial light. There were some downsides to it. And what I really want us to think about is every time we've kind of leveled up in technology, it usually wasn't always 100% plus. There were some negatives that we brought along with us, and we weighed them out. And we said, hey, the goods exceed the bad. But then when we add them up over time, we're like, how did we get here? So we'll address some of that today. Go on to the next slide. Here's some oil lamps, and they're kind of simple and beautiful, right? Then we move on to the electric lamp, right? And that started in the late 1800s. We all know the incandescent lamp, which some of the original ones or some of the retrofit style ones still have some beauty to them, right? They're still kind of sought after, and I see them in coffee shops and restaurants all the time. They're really to create an atmosphere, not to create the primary light for areas today. But you guys are the designers, and you guys are the ones that decide what we use. I am not here to tell you what lights to use and what not use. That's up to you, right? You guys are the keepers of the beauty and of the design. But when we use a different type of light or a different type of light fixture, we have to deal with it in a different fashion, right? So we've got electric lamps. They're fantastic. And man, here's some beautiful ones, right? Here's what we used to do with these back in the day. Because the first electric lamps were not built into our homes. They were lamps. They were floor standing and table lamps. And eventually we started building them into the homes, right? Here we go. Now we started building lighting into homes, right? That started happening in the early 1900s, where they said, hey, instead of just plugging the lamp into a wall and having a switch on it, let's make it part of the room. And if you think about it, that was one of the first real technologies that became standard inside a home, right? Then, a couple of decades later in the 50s and 60s, we moved to fluorescent lighting. And I can't hear you guys, but I can hear everybody groaning right now about fluorescent lighting. And I don't disagree, but we do have to understand a little bit about it of why did we adopt something that was really, really not great in so many ways? Well, the fact of the matter is it did do some things better than other things, right? It cost less to operate, it used less energy, it lasted longer, um, it could stay on for longer periods of time without failing. Um, but we all know the negatives. The negatives were we didn't really like the color of it. It didn't dim very well. The light quality was kind of poor. And unlike an incandescent, over time it degraded, right? If you were looking at an incandescent bulb and it was 10 seconds away from failing, it looked the same until it failed. A fluorescent bulb degraded over time, and you could tell. And none of us like that. And when I talk about fluorescent, it's fluorescent and all its kissing cousins. But the most important thing that we need to remember about fluorescent lighting is our industry had to learn all new technology, right? All of a sudden, when we were using incandescents, we didn't have things called ballasts and starters. And we had a whole different technological design to use fluorescent lighting. And if you used the same techniques that you used, if you wired up an incandescent light exactly the way you wired up a fluorescent light, it didn't work, right? So electricians in the industry had to learn new techniques for a new style of lighting. And please remember that because that's going to be really important when we move on to LEDs. And now we have this, right? And it's a lot of times it's not particularly attractive. It looks more plasticky and techy, and we don't always love it, right? Um, but hopefully we can use the best technology and make it beautiful, right? The next thing that we added onto our homes was the wall switch. If our original lamps were table and floor lamps, well, then we didn't have a need for a switch, right? Well, eventually we added a switch to the wall and it turned the dimmer on. It turned the outlet on and off so the light could be on the other end of the room and we could turn it on and off from here. But it kind of caused a problem because there was probably a light on the switch as well. And I think we've all been in a room that had a switched outlet where somebody turned the lamp off and then you couldn't turn it back on from the switch until you walked out back over to the lamp. So we solved a problem and created a problem all at the same time. And we've probably still dealing with this. I bet you there are rooms in a lot of your houses that still work like this. You're like, oh, somebody turned the lamp off at the lamp and now the switch doesn't work. And then we changed the first floor of our homes massively because of one room. We changed our kitchen, right? In the future kitchen, it had an island and it didn't have walls and it connected to the eating area. And we opened up our entire first floor, right? And obviously, I think most people love this, right? Everybody, this is the standard today. Nobody says, I want it closed. Everyone says, I want it open. I want it big, right? And that's great. But it did have an effect on how we did lighting, right? And it had a pretty major effect. And here's some other I love these old 1950s photos of the future kitchen. Um, and this one, if we look here on my left, if you notice it, there's an office table or an office desk with a phone and a notepad and a chair right in the middle of the kitchen. And I think that's, well, it's pretty telling because I think we all have something like that today because, I mean, kids do their homework in the kitchen, right? People go to their office at home and work out of their kitchen. I see this all the time. But when we did this, we started adding multiple lighting circuits. We're like, well, wait a minute. Instead of just putting the lights in the ceiling, we can do all sorts of things with them. And this is kind of the standard layout for most lighting circuits in a kitchen. And you guys might have a different feel on this, but I would think most people would agree that these are pretty standard lightings in any modern kitchen being built today, right? And that is the sink over the stove, main cooking area, main eating area, definitely the island, because the island is the biggest part of the kitchen. We love our under cabinet lighting. And if we have glass cabinets and we want to light the inside of them, we need inner cabinet lighting. And if we have a space over the cabinet between the top of the cabinet and the ceiling, we're going to do over cabinet. And kick and other accent lighting is becoming really common as well, right? And let's be honest, that's really making our homes a lot more beautiful and a lot more design focused. So between these open floor plans and a removal of doors and all of these extra lighting circuits and the kitchen becoming the hub of the home, we came up with a solution for this because we couldn't just have a light switch by a door because there wasn't a door anymore. And that opening has to control the light switch there has to control lots of lights in the room and some lights in the other rooms, right? We have a sliding glass door that goes outside. So we need a light there to control the outside lights. So what happened is we came up with the dreaded three-way. And if you guys probably all know what a three-way circuit is, but the most common one we know about or remember is, hey, there's a switch at the top of the stairs and there's a switch at the bottom. And whatever you press one way, the light will turn on or off if you just change its state. If it's up and you put it down and the light's off, it'll turn on. And then the other one will do the opposite thing. And they're a little annoying because you never know which is on and off, and they don't really work with dimmers. But we needed a solution to have multiple switches for one light. And that's what we came up with. It had some benefits and it had some disadvantages as well. Wall switches. Yes, I love looking at these antique ones. These are pretty old and need some love, but man, when they were brand new, they were a lot more artistic than the ones we use today. We use ones like this today, or we still see them, and not particularly attractive, but I'll show you some other ones as well. Guys, am I going too fast? Kind of whizzing through this. Want to make sure everybody's still with me. Great. So we move on to the dimmer, and it really became adopted largely in the 1970s. And it was mostly just to replace, right? Hey, I've got an incandescent chandelier, or I've got an incandescent lighting circuit. I want to vary the amount of light it puts out, so I put in a dimmer, which is just something that variably controls voltage. Hey, 120 volts is the max voltage in the United States. It's 220 overseas. And if I send 100% of the voltage, I get 100% of the light. And if I send 50% of the voltage, I get 50% of the light. And it worked out pretty well. And people started replacing their switches with dimmers in their houses. And they looked kind of like this. And it dims, which is great. It creates moods, which is great. And it saves energy, also great. But it doesn't work with the three-way circuits that we have all over our house now, in every stairway, in every room with an open architecture, in every room with two entries. There's got to be a device on either side. So our dimmers don't work well with those. Then we came up with smart dimmers. I'll probably skip over this and jump back to that in a second. But when we started to use other type of lighting, we quickly noticed that the dimmers don't really work very well. So we had to come up with some software solutions, which were Band-Aids, and I'll jump back into this in a moment. But then between our three-way dimmers, meaning having multiple switches for one lighting circuit, and having lots of lighting circuits, I started noticing this in houses. And this is, good old-fashioned light switches. Some of these are multi-million-dollar homes that were delivered to clients like this. I don't think it's particularly intuitive. I don't think I know what happens before I press a button, and I definitely don't think it's particularly attractive. And I'm sure you guys would all agree. And we see this all the time. I like to call it wall acne, right? Because The walls just grow more technology over time if you don't do something about it. There's some other ones that I actually took these photos myself. Yes, there are some houses out there that look like this. And I'm sure this didn't start off like this. I'm sure it got there over time. Well, since we were in the 1970s, the next thing that happened to lighting is the Light Saber was invented. And mind you, that's everybody's favorite light. We're still waiting for one today, but yes, it has multiple uses. It's a great portable light. You can cut and toast your bread at the same time. You can mow your lawn. I personally use it to warm my coffee. And every once in a while, when those dark lords are around, it keeps them away. So there's my little homage to Star Wars and lightsabers. But really, the next piece of true technology that we're using is LEDs. And really, that's the crux of what we want to talk about. So if we just quickly compare LEDs to incandescence and fluorescence, well, incandescent, the second you turn it on, it lights up. Right before it dies, it looks the same. But a fluorescent, when you turn it on, it doesn't turn on right away. It takes a while to warm up, and the color quality degrades over time. LEDs have a lot in common with fluorescents. They do turn on right away, but they don't dim, and neither do fluorescents. And I'll explain to you why they don't dim in a minute. And the color quality of an LED degrades over time. So people say, well, these LEDs last forever, right? They'll last my lifetime. Well, they actually do fail, and it's usually not the diode. But if the color quality degrades in an LED, that means if you have a whole bunch of LEDs that are set to a particular color temperature, and then you replace some because it went bad, well, if it's been a bunch of years down the road, that fixture is going to have a different color to it. And that's not great. So, because nobody wants to replace them all. But a few engineering facts about LEDs is they're all low voltage. They're all DC low voltage. And the power that comes out of our home is AC high voltage, which requires a transformer to bring that power down to 24 volts. Why do LEDs stop working 99% of the time if you have a bad LED? The reason is not the diode, not the actual light element, but the transformer typically has gone bad. The device that stands in between the power of the house and the LED, because that transformer makes heat. And heat is the thing that kills electronic devices. We all know heat rises. So if you're using a device that's getting hot, why would we put that in the ceiling? We have a device that makes heat and heat rises and heat kills devices. Why would we put that transformer on the top of every light fixture in the ceiling? I see that all the time, right? And we absolutely believe in remotely mounting the transformers, which we will show you in another slide on here. The other thing, two very important factors that I'm going to repeat twice here. LEDs are only available in red, green, and blue. I'll say that again. LEDs are only available in red, green, and blue. No one here has seen a white LED. And I'll jump into this. What you have seen is red, green, and blue combined together to make white, because nobody has invented the white LED yet. And the other thing is LEDs aren't dimmable. When they have enough power, they turn on. They're a digital device. And when they don't have enough power, they turn off. But we can go to Home Depot and look at a row of LED bulbs, and every one of them says dimmable on it. Well, the way we really dim a diode is we turn it on and off. Now, let's not get that confused with everybody seeing their LEDs flickering. Right now, there are LEDs on me that are set to, 50% probably. And That means they're pulsing on and off 50% of the time in the second. And because I'm on video, if the frame rate happens to match, you'll see this. You see it in car commercials all the time, and it kind of looks neat. But when you see a slow motion shot of a car, you can see a lot of the lights look like they're flashing because that's the LEDs that are being dimmed in the car by turning them on and off, and the frame rate of the camera catching them. There is no white LED. Red and green have been around for decades. In fact, the red LED was the first one invented, and I believe that was invented in the 1960s. And in the 1970s, the green LED was invented. And all of us, children from the 80s and 90s will remember every tape recorder, CD player, VCR, or any device we ever had red and green LEDs on them because they were the play and pause on all our devices, right? Well, in 2014, the Nobel team gave the Nobel Prize for Physics to a bunch of scientists from Japan for the blue LED, right? Well, wait a minute. The people that invented the red LED didn't get anything. The people that invented the green LED didn't get a Nobel Prize. So I like to kiddingly say the people at Nobel must really love the color blue because they gave the Nobel Prize for Physics away for it. And the reason that really occurred is a much more scientific one. Well, we had red and green. And when you add blue to red and green, you get white. So inventing the blue LED, yeah, it got us blue, but it actually gave us the ability to generate any color we wanted, including white. And that was really important. But when they started hitting the market about a dozen years ago, everybody said, oh, I don't like these. Oh, they're not ready. Oh, they look terrible. It's too cool. I want a warm white. And I absolutely agree. But the reason that occurred is the manufacturers just started taking these red, green, and blue diodes and spinning together, giving you a third, and a third ratio. And that landed us on a mathematically true white. But it wasn't the white that we wanted. So we started over time to edit or, the ratios to change the color or the color white. We can adjust the color white by adjusting the ratio of RGB. Now, I know a lot of you will probably say, I've heard of so many designers, I want 2700 Kelvin and I want 4000 Kelvin or I want 6000 Kelvin, and people talking about this in Kelvin. And I typically like to say, if you're talking about the color white on an LED and you're using Kelvin, it typically tells me that you really don't know how LEDs work or how they're rated. To determine the color, it's really a ratio. It's not a Kelvin rating. A Kelvin rating is actually a measurement of heat. I have this little video I made here. So here we go. I'll just quickly go through this. Red, green, and blue. Those are our 3 LEDs. Now what I can do is I can combine these LEDs together to make white. But then what I can also do is I can make presets. So the light to the right, I made a preset and I adjusted the ratios to make it what typically people would call a very warm white. And warm white is not by using a different Kelvin, it's by changing the ratio of how red and green and blue are working together. Any color or any color white. So here's how I typically see things wired. Somebody buys some hi-hat or some fixture. It has the transformer on top of it to convert that 120 volts down to 24 volts DC. And they stick that up in the ceiling. Now, if you connect a switch or a dimmer to a transformer, especially if it's a dimmer, if you connect a dimmer to a transformer and you dim it, the lights will flash or they won't dim or they'll flicker, or very often you'll hear them hum. You hear the transformers humming. And that's them screaming for help. They don't like it. They're not healthy. They don't want you to dim the power going into them. That's not how they work. So this is a typical scenario that I see wired, and you will never get color control or good dimming out of this methodology, right? And here's another quick video I made.
Okay, guys,
when something's wired this way. And I've got, well, I'll explain it right here.
I have an incandescent light there, and I have an LED light there. That's the chandelier, so it's really obvious. That's a hi-hat. They're both connected to this very high quality dimmer. It's a name brand dimmer, probably around $250 for that dimmer. And we're gonna ramp this up slowly over the period of 5 seconds. And when we ramp it up, let's watch what the lights do. And then we'll ramp it down. And back up once more time.
So if you guys see, that incandescent is fading on and off nicely.
Incandescent very clearly fades on and off nicely, and the LED kind of pops off.
That's not from using a low quality part, right? That's from actually using a high voltage dimmer on a low voltage light. And all LEDs are low voltage lights, right? This is a schematic, and this might be a little over some people's heads. But if we look at the very bottom one, it's the simplest. So we have a 24-volt transformer, and that's simply plugged into the wall with a regular outlet, and it's in a closet or in a basement. And then that low voltage wire travels throughout to the home to the fixture, where it has an LED controller on it. The LED controller gets 24 volts in all the time, whether the light's on or whether the light's off. And then it splits that power into 3 individual controllers, one for red, one for green, and one for blue. And so you're like, great, if I want red, I turn red to 100%. If I want green, I turn green to 100%. If I want blue, I turn blue to 100%. And if I want white, I turn them all on. But then we talked about adjusting the ratios, which means I need to be able to have less output from one or several of the diodes. But how can I do that if it doesn't dim? Well, we dim it by pulsing it on and off, like I mentioned before. So this controller will do, if you turn it on, if you turn the blue channel on to 100%, you get 24 volts out. If you turn the blue channel to 50%, you get 24 volts out. You just get it pulsed 50% of the time within 1 second. So you're still getting 24 volts out. It's just you're getting 24 volts out for less time. This is called duty cycle. And duty cycle is something you're familiar with. It's not the way you drive your car. You don't drive your car and put the throttle all the way down and lift it all the way up. You kind of have variable rates. But your air conditioning and your heat works off duty cycle. It works over minutes or hours, but when you turn the heat on in your home, it turns on to 100% until the temperature gets up to where it needs to be, and then it turns off. And then when the temperature drops a couple of degrees, it turns back on at 100%. And that's called duty cycle. We're doing that same thing. We're just doing it within 1 second. So these very simple controllers can control a whole bunch of lights, but very commonly on modern lights, it's built into the light. So you can just wire 24-volt power to it, have a bank of transformers in a nice cool closet or a basement, and you can control the individual diodes on every LED fixture in your home. Typically, there's a language that controls them, and DMX seems to be the most common language being used. DMX came out in 1980, so it's been around forever, and pretty much every lighting manufacturer supports DMX. It doesn't mean that that's the protocol that you have to use, because what language you use to talk to this device down here isn't nearly as important as having that device. So if we just talk about powering up our LED lights. I use the word transformer. For some reason, the industry commonly uses the word driver. And I like to say that, well, the driver, that's the guy that works for Uber. A transformer is something that transforms high voltage power to low voltage power. And we can see them in these three pictures here. One of them, it's got hanging off on the right-hand side with that transformer bolted to the end of it. Another one has an external box with a wire running to it. And the one on the bottom has the transformer built into the back with this big giant heat sink on the back of it to get rid of the heat from the transformer. So let's do some quick math, accounting math. If we had 25 lights and they were 20 watts each, we would need 500 watts of transformer power. If you bought those transformers from the light manufacturer, and by the way, I'm not picking on lighting manufacturers, but pretty much every lighting manufacturer, almost across the board universally, does not manufacture their transformers or drivers. They buy them from somebody else, right? Commonly a company called Meanwell. And they make a fantastic product, and they're not evil for doing this. They're not in the transformer business. But if we can buy 500 watts of transformer power for about $75, or we could buy one 20-watt transformer for about $20. Well, one way we need one transformer, and the other way we need 25. So if you add that up, it's about 15 cents a watt versus $1 a watt. Now, somebody might say, well, if I only have one transformer instead of 25 of them, if that one transformer goes bad, all my lights don't work. Yeah, I have an answer for that. There is definitely a solution for that. But the odds of that transformer going bad are much, much, much lower because A, it's not mounted in a ceiling. It's mounted near a floor in a closet or in a cool basement. And it's not connected to a dimmer, so it's not being fed variable power all the time. So its reliability will be significantly better. Plus, it can be something like the size of a shoebox and have a lot of heat dissipation on it because it doesn't have to fit in a ceiling. So it is going to be significantly more reliable. However, what we would commonly do is if I needed 500 watts of power for lighting in a home, I would probably put in two 500-watt transformers. So I have 1,000 watts of capacity. Either transformer could go bad. The customer wouldn't even know, right? Because I still have 500 watts. And I can still do that for less cost in materials, less wiring, less maintenance, and less labor than putting a transformer in the ceiling for every light. And by the way, you will get true color control, you will get true dimming. So in every way, it's better. These are some examples of some large transformers, right? 480 watt versus a 20 watt. We talked about this before in the last slide. And there's my comment about a driver being the guy that works for Uber. So there's our simple math. But these transformers are all made by the same manufacturer. Meanwhile, it doesn't mean you have to use them. They're just kind of the 800-pound gorilla in the industry. And yeah, if you buy one larger transformer than multiple smaller ones, it saves a ton of money. So now we have dimmer types, right? So we need to control the lights. We need to control the red, green, and blue channels, which is how we're going to make our different whites. It's how we're going to do our circadian rhythms. It's how we're going to make our home feel and look beautiful, right? So we have forward phase and reverse phase, also called ELV. Those are high voltage dimmers. Those are meant for incandescent lights. If you're putting a high voltage dimmer on a light, it should be a high voltage light. And there is no high voltage LED light. Simple. 0 to 10 is another technology that does work on LEDs, right? Dolly and DMX. And then a lot of companies have their own proprietary language. Lutron, the most common one. Lutron doesn't talk in open language. All of their dimmers and lights talk to each other through a proprietary radio frequency. And whether it's proprietary or not doesn't mean it doesn't work. right? And then we've got smart bulbs, right? Well, smart bulbs, yeah, you get color out of them, and yeah, they dim perfectly, but they're not easy to use. A lot of them are ugly. And who wants to use an app every time they have to turn their lights on and off? That's no fun. And then what do we put on our wall? We talked about wall acne. Man, look at all this wall acne. It's really ugly. And yes, these are real photos from real homes that I went to and took photos of this. Here's another one of them. Here's another one of them. So what do we do to make our home very, very, very easy to use? It needs to be grandma friendly, right? If you have to take notes on how to use something, you've designed it wrong, right? I've had customers pull out a pad of paper. Okay, I'm going to show you how to use it now. And they pull out a pad of paper and I'm like, put the pad and paper down. If you needed notes, if you need to write it down, I didn't do my job right. I personally like to not go larger than 2 gangs. By the way, if everybody doesn't know, this is a single gang. I don't like to go larger than 2, but sometimes the hole is already there. What the homeowner asks for and what they want are not always the same, right? I can give you what you want, or I can give you what you're asking for, but they're probably not going to be the same. So I believe in scene-based control. You have a button that turns on the room to the correct lighting level for that time of year and that time of day. You just press the button that says kitchen and the kitchen will come on. All the right levels, all the right color temperatures. And we call this the rule of 99%. If you press that same button at 3 o'clock in the morning, it's going to do something radically different than if you press that same button 3 o'clock in the afternoon. If you press any room name button, if you press that kitchen light button in 3 o'clock in the morning, it's going to go into midnight snack mode. The lights are just going to barely creep on. You wouldn't want it to go to the same scene that you would at dusk or at dawn or in the middle of the day. Here are some other layouts that we've used. I think these are a little more obvious. You know what it's going to do before you press the button. And I do believe in having them backlit. I absolutely believe in having them engraved either with symbols or with words. And it should be really, really, really obvious. And now this is just one brand of light keypads, and I can show you some others as well. Here's keypads as well, right? And now off to the left, there is a triple gang. Why? Well, we had a triple gang hole in there. The customer it was a retrofit. They didn't want to rip the walls open. So we put back in a triple gang, but we laid it out. So we thought it was clean and easy. We've got a double gang on the right-hand side and on the bottom. And I think you can really make these kind of fade into your home and become part of the architecture. I love these. These are kind of turn of the century, good mechanical buttons, right? That we connect back to our technology. So you can press these old-fashioned brass and stainless steel knobs and buttons and have your lights and your shades do things. Forbes and Lomax and Meljack are kind of the classic manufacturers of these guys. You definitely need an integrator to make these work and do the technology, but I think they're beautiful. And I found these on the internet. Don't do this. I don't know where this came from, but I was completely entertained by these. Somebody went a little overboard. So steps for a lighting project, right? First, you need to have the architect and the furniture layout for the room, right? You remove the lights. Most architects, even amazing ones, even amazing interior designers, they do 4 cans and a fan. Hey, I did 4 hi-hats and a fan in the middle, right? You really want to use a lighting designer. I'm not a lighting designer. I know enough about lighting design to be dangerous. I know about technology, but I've worked with a lot of great lighting designers, and what they typically, the best ones in the world just don't do a grid of lights in the ceiling that does a great job of illuminating the floor. They usually do accents, and there's a whole science to the art of lighting design. So You present this plan to a lighting designer, involve the integrator, right? We used to be called AV guys. We don't like to be called AV guys any longer. We're integrators. So have your lighting designer and your integrator work together, and they will execute on the lighting design and the keypad design and the programming, right? We talked about score before, right? Moving to fluorescence, moving to LEDs, putting lights built in, having multiple lighting circuits. So if we don't actually add some technology to a room and you want to do modern lighting, well, you're going to have light switches everywhere. Your LEDs, which is probably what you're going to wind up using these days, are not going to change color temperature or color at all. They probably won't dim well. And you're going to have a lot of junk on your walls. Now, I'm not saying that that's happening to all of you, but if you use old-fashioned methodology, you're going to get old-fashioned results. What's worse is if you use old-fashioned methodology, and there's nothing wrong with that methodology, but on new high-tech things, that's even worse, right? You have to use the right techniques for the right systems. And guys, I kind of whizzed through that pretty quickly. If you guys have any questions.
Thank you so much, Keith, for presenting. I do have some questions on my end, but yeah, if you want to leave that slide up so we can see your contact information, that'd be great. Our first question is on those keypads that you've shown. Our audience member asked, what are your thoughts on keypads versus touch screens?
Great question. So here's the thing is typically that question is not asked of me because I'm not the designer. You guys are. So, but my humble opinion on it is I want keypads in most of the places. The places I want a touchscreen is definitely on the wall of the kitchen because we live in the kitchen, and a keypad is a great way to do something quickly, but you can't do everything. You can't make the music come on outside from a keypad. I mean, yes, you could, but then you'd have a million buttons on the keypad. So I like to keep keypads focused on lighting and shading primarily. That's like 90% of the time on the buttons, right? And keypads for the rest of the home, typically keeping it to single or double gang boxes. And that's pretty much the best answer I can give.
No, that was perfect. Thank you. Our next question is, are there any regional building code differences regarding lighting, or is the code for use mostly the same in North America?
So, wow, that is, if anybody's ever read the code book, anybody that's read the code book cover to cover, my hat's off to you because that's crazy. It's like reading an encyclopedia. Typically, the codes are the same. They are slight differences from state to state, but most of the United States has about the same building code for electrical. You have to have outlets in certain locations. You have to have wet stuff available, wet approved stuff in wet areas. And if you're doing high voltage lighting, meaning, incandescent, you need an electrician's license. So there are slight variances, but the concepts work pretty much in every state.
Perfect. Sarah asked, how does the dimming feature work on smart bulbs? Is it the same pulse rate like a regular LED, or are these better in some way?
Great. So without going into a particular brand, if you buy a smart bulb all in one, it is an LED diode. Obviously, it's a housing. It's an LED diode. It is a LED controller and a transformer all into one. So whether you bought a $20 one at Home Depot or whether you bought a $1,000 one someplace else, they work on that concept. Smart bulbs are meant to thread into existing high voltage, right? So it's a retrofit situation. It's not you wouldn't use smart bulbs in new construction, right? And then there's just a way to communicate with that bulb, typically through radio, Bluetooth, Wi-Fi, Zigbee, Z-Wave, some radio technology communicates with the bulb. So you use your app, you send a command to that bulb in some way, and the bulb does what it's supposed to do. Here's wherein lies the problem. And it will work well. It will not flicker, it will change colors, it will do all of the things that LEDs are supposed to do because it's a fully contained system in one device. But it's probably connected to a light switch. And then when you turn that light switch off, great, the light turns off. And then you pull out your app to turn the light back on, and it doesn't because there's no power there. So using smart bulbs has the same problem as using a switched outlet when you plugged a lamp into it. If you turn it on and off in one place, you can't turn it back on unless you go back to that place and turn it on. So we can use smart bulbs, but you really need to use an integrator that's going to remove that wall switch so there's power for the smart bulbs all the time, and put a device that looks like a wall switch, like our keypads, and presses the button. When you press that button, if you have smart bulbs, it actually sends the command to the smart bulbs. So it's very difficult to use smart bulbs in the correct way where you can't accidentally break something. I don't know if that's helpful.
That is helpful, and that makes sense. I have a similar situation in my own home with the wall switches, so I appreciate touching on that.
If you can press a button in your house and it breaks something, you've done it wrong.
We need someone to help us out. Patricia asks, what is the right question to ask my electrician regarding lighting in the kitchen? We are wiring a new construction house now, and there are so many switches. How can I guide the electrician to keep it simple? Homeowner is not hiring an integrator.
I have worked with a lot of electricians over my last 3.5 decades in business. And the person I learned everything from was my hero, my grandfather, who was a union electrician for over 50 years. That being said, electricians are needed, smart, intelligent, hardworking people. But I have met very, very few of them that understands anything in this webinar that I've explained. And they are trained and tested and certified on high voltage. That's all of their career. So most electricians are not really fully equipped to understand how to install LEDs properly. You would typically need somebody that understands how to get rid of all the switches and getting the lights to do the correct things and getting rid of the gang boxes and getting them smaller requires technology and a little bit of software and some knowledge. And that knowledge is not in the electrician's hands. So I don't know, you really need to get somebody that understands it and have them talk to the electrician and lay out the lighting plan a little bit, where the wires are going and what's going on. I don't know if the electrician is going to be able to handle it by themselves, or else you wouldn't be in the situation you're already in.
We appreciate that insight. I think that's a good answer. Our final question from Rosa is, what are your favorite brands for light switches and keypads?
Oh God. Everybody's got their own favorite flavor of ice cream, but you usually have a bunch. And mind you, I get this question a lot. What's your favorite thermostat? What's your favorite TV? What's your favorite speaker? What's your favorite door lock? What's your favorite? What's your favorite? What's your favorite? And the best advice I can give you is if you ask that question to somebody and they give you an answer without asking a whole bunch more questions, don't believe the answer. So if I said, oh, I love Meljack or Forbes and Lomax or Lutron or Control 4, well, those all have radically different looks and feel. They all work with radically different technology. They all work with lights. So the question is what is the right look and feel for you guys? You guys are the designers. You guys are in charge of look, feel, and smell. You guys are in charge of emotional connection to the room. We're in charge of software and tech, right? So what is the best one to use? There are tons of great ones, and you should find the ones that fit the design that you have imagined for that home or that room.
Perfect. Well, thank you, Keith, for sharing your insight. Before we end today, do you have any final thoughts for our audience?
Absolutely. My information's here. There are 25,000 integrators in the United States of America. You can all find them through CEDIA but if you're going to work with an integrator, which I do recommend, go and visit their showroom. If they don't have one, move on to the next one. If you have an integrator that's, less than a half a dozen people in the company and they're operating out of their vehicles, they may be great people. They may be smart. They may be hardworking, but they don't have the time and the energy to actually develop a lighting plan in their showroom.
Perfect. Thank you again, Keith. And thank you again to Hardware Resources for generously sponsoring this month's webinar series. Until next time, I hope you have a great day.
Bye, guys.